In this video, we'll be looking at 5.2, Division of Polynomials. Term, polynomial. This prefix poly means many. Nomial means term. So polynomial is literally many terms. Here's a definition from our ebook. I wouldn't suggest that you necessarily write this down. You do have this available on XYZ. A polynomial function of degree n in x is any function that can be written in this form, where a sub n is not equal to 0. That is, this leading term, you can't have a 0 coefficient or it wouldn't be there. And n is a non-negative integer, so this exponent must be positive. That is, if we had something like 1 over x squared, well, we know we can rewrite that as x to the negative second. This is not a polynomial. This is a rational function when we have this a polynomial in the numerator and in the denominator. So a polynomial, we cannot have a negative or even fractional exponent. If we had a square root in there, square root of x, it wouldn't be a polynomial either. All right. Also, not a polynomial would be the square root of x. This is not a polynomial. This would not be a polynomial. A polynomial would be a cubic or a quadratic. All right. Okay. First, let's look at division by a monomial. Division by a monomial. So monomials are a subset of polynomials. Mono there is one. So here we're talking about one term. In this case, the divisor will just be one term. And this is going to be one like number 1. Example number 1 from your XYZ. All right. When you divide by a monomial, what you're going to do is break up the fraction. So let's say we have this problem. This is number 1. 8y cubed plus 12y squared minus 16y, and we are dividing that all by 4y. All right, so here again we're dividing by a monomial. The divisor, the denominator, is one term, 4y. Well, what I'm going to do is break this quotient up into these 3 parts. I'm going to look at this first division, that is 8y cubed over 4y. And then I will look at this second division, 12y squared over 4y. And then lastly, minus 16y divided by 4y. And the operator I left here in the middle. All right. So 8y cubed divided by 4y, 8 divided by 4 is 2, and y cubed divided by y to the first is y squared. When we're dividing, we subtract the exponents. Plus 12 divided by 4 is 3, y squared divided by y is y. And then lastly, 16 divided by 4 is 4. Preserve my operator. Y divided by y is y0 or 1. We don't have to write that times 1 here. So this is my quotient. Now we will look at division by polynomials. In this case, we're going to have a polynomial divided by a polynomial. We're going to look at 2 methods. One, factoring, and 2 long division. Alright, first the factoring method. And this problem is much like number 4 from XYZ. Alright, let's say we have x squared minus 2x minus 3, and we are dividing by x plus 2. Pardon me, x plus 1. In this case, we have a polynomial 3 terms in the numerator and a polynomial 2 terms in the denominator. So what I'll look to do is factor this numerator. Well, we are certainly, it is a trinomial, so we can use our big X method. But one thing that you need to be on the lookout for is we're going to have 2 factors up here, and one of them is going to be this x plus 1. So use that as a clue. I'm going to show our big X method, but know that in this case, it's going to be a little bit easier to factor. In the bottom is a times c, that is 1 times negative 3. And the top is b, negative 2. And negative 3 is prime. It's only 3 times 1. If this is negative, 1's a plus, 1's a minus. Since it's 3 and 1, and I need this negative 2 sum, the 3 will be negative and the 1 will be positive. So these 2 terms go here. But notice, as I said, x plus 1 was going to be one of them. So if when you're doing the division by factoring, expect that one of these terms will be that bottom one. You can use that as a clue. Now I can divide x plus 1 and x plus 1, leaving only x minus 3. Alright, now let's look at the long division method. Long division. This will be like number 7. Alright, let's say we have a cubed plus a squared minus 9a minus 9, and we're dividing by a minus 3. Alright, so first I'm going to rewrite this as a division with this is my divisor, a minus 3, and we're dividing into, this is my dividend, a cubed plus a squared minus 9a minus 9. Alright, this is long division, much like you learned long division way back in grammar school. I'm going to look at a division of 3 into 1,199. Let's recall how we did this. Well, we say, hey, 3 will not go into 1, but 3 will go into 11. It'll go in there 3 times. I multiplied 3 times 3 to get 9. And then I did this subtraction. 11 minus 9 was 2. Okay, very similar situation here. I'm going to look at this first term a, and I want to know how many times it goes into a cubed. Well, it goes in a squared times because a cubed divided by a is a squared. Same thing here. 11 divided by 3 is 3, isn't it? All right, so now here I multiplied 3 times 3 to give 9. Here I'm going to multiply a squared times a minus 3. Well, a squared times a is a cubed. A cubed times minus 3 is a minus 3a squared. Okay, well here I subtracted. 11 minus 9 was 2. Here I'm going to subtract as well, but when I subtract this binomial, I need to change both signs. This one becomes a negative, this one becomes a positive. So these two add to 0. 1a squared and 3a squared is 4a squared. Okay, well here I would bring down my 9. Here I'm going to bring down this minus 9a. Alright, again, here 3 into 29 would go 9 times because 29 divided by 3 is 9. And then 9 times 3 is 27. Same thing here. I'm looking at how many times does a go into 4a squared. Well, it goes into it 4a times, because 4a squared divided by a is 4a. Now I'll multiply. 4a times a is 4a squared. 4a times minus 3 is a minus 12a. Alright. Over here we would subtract 29 minus 7 to get 2. Here, again, subtracting means I'm going to change both of these signs and then add. This cancels to 0, adds to 0, I should say. Minus 9a plus 12a is a plus 3a. Now lastly, bringing down my minus 9. Over here, we'd bring down this 9. 3 goes into 29. We would say 9 times. Here, a goes into 3a 3 times, because 3a divided by a is 3. Now multiply. 3a times a is 3a squared. That's 3a, pardon me. 3a times minus 3 is a minus 9. Well, changing these, you can see you get 0. Here there is no remainder. Alright, so this is my quotient. This is the answer. A squared plus a plus 3 is the quotient there. Let's look at one final problem. This is like number 9. Right. Let's say we have 6x cubed minus 4x squared plus 1, and we're dividing by 2x minus 2. Well, again, I will first rewrite this statement as 2x minus 2 divided into. Alright, here's where it's going to be slightly different. You notice in my first one, I had an a cubed, a squared, a to the first, and then a constant. From my leading power, there was a decreasing power for each one of them. A to the second, a to the first, and then a to the 0, that is the constant. But here we have x cubed, x squared, but no x term. What we need is a placeholder in there. 6x cubed minus 4x squared, and we need a placeholder for our x term. We will simply write 0x, because 0 times x is 0. Lastly, plus 1. Okay, and now it's going to progress just as our previous one. How many times does 2x go into 6x cubed? It goes in 3x squared times. Simply, 6 divided by 2 is 3. X to the third divided by x is x squared. Now multiply. 3x squared times 2x is 6x cubed. 3x squared times minus 2 is a minus 6x squared. Changing my signs and adding. This cancels. Negative 4x squared plus 6x is a 2x squared. I'm bringing down my placeholder 0x. Okay, how many times does 2x go into 2x squared? X times. Because 2x squared divided by 2x is x. So multiplying x times both of these terms gives 2x squared. X times minus 2 will be a minus 2x. And here you can see the importance of that placeholder, because we would have had unlike terms there if we'd have brought down that 1 now. Now, changing my signs to affect my subtraction. This sums to 0, and then 0x plus 2x is plus 2x. Lastly, bringing down my 1. 2x goes into 2x one time. 1 times 2x is 2x. 1 times minus 2 is minus 2. Changing and summing, this goes to 0. 1 plus 2 is 3. This is my remainder. When we have a remainder, we simply place it over the divisor. Let's go back to this problem here. Here, if I said, hey, 9 times 3 is 27, I would have this 2 left over, minus 2. positive 2, that would be 29 minus 27 would be 2. I would write this 2 as 2 over 3, wouldn't I? We would say it's 399 and 2/3. All right, this, my remainder, I express over the divisor. Same situation here. This is my remainder. It gets written over my divisor. So here I would have plus because this is positive, 3 over 2x minus 2. So this is my quotient. 3x squared plus x plus 1 plus 3 divided by 2x minus 2. Alright, that concludes this video.